ready for this thing. So I don't have to introduce again Professor Irad Bengal, that will be our first speaker in this session, but this time we'll share with you one of his specific topics that he's now involved in. Please.
Okay. Thank you very much. So aspects of human aspects in cyber, of course, are very important, and I will have several presentations also by Dr. Eran Toch, and some of the students will present later. And this is a joint work with Alon Sela, my PhD student, that will share with me a part of the presentation, as well as Erez Shmueli, another member in our department, with collaboration with Professor Pentland from MIT. The original work was not related to cyber, but it's very much relevant to cyber. And when we talk about human factors, let's say that we want to place some malware in the centrifuges of Iran. I can speak freely because I don't know anything about it. So either you can do it physically, you can send maybe a technician, one of the German technicians that works there, and he will put a smart key inside, and a thing will happen. We learned that now Israel is accused by planting some malware in some of the Geneva hotels where the talks against the nuclear, the Iranian nuclear program, or for the nuclear program, where there were progress. So this is one option. Another option, of course, is to plant such malware in the network, in a website, maybe in an ad, and hoping that someone will actually would go and press for it and will do the link, or to try to do something with the social media. And this is exactly where this research comes into play. We are talking about information flow in human networks. By the way, also the talk later by two students, Nancy and Michal, will be focusing on way to attack by using a naive user in the organization. And the question is really what is the best approach from the bad guy perspective? Should we put it in the web, hoping that someone will get into it, some honeypot that will attract these potential naive users, or should we try to do something more actively with the social network? And these were the two main methods of a malware spread, or actually of information spread originally, that we question. So we call them web. The web are, again, all these malware installed on, so to speak, innocent web pages, or to do something through a personal connection by a social network, which we call word of mouth. Okay, so the idea is that your friend will send you some invitation to a cool link, and maybe in a few time another friend, and then you'll be pursued to do that, and by that you will arm your organization. Now, when you do that, one has to consider that the way that web pages are ranked in the internet is very much related to what is called page rank. There are many versions, but the most naive and quite till now quite accurate model is that the rank of the web is relevant, or is proportional to the rank of all the web pages that are connected into it, with some penalty if these are very popular web pages. So if you are if many popular web pages link into your web pages, and specifically if they are popular but they select carefully to which they point to, then you are becoming more and more popular. And of course, this creates a situation where popular websites and popular web pages become more and more popular, okay? And of course creates a situation where if you have a new idea, it's very hard for you to go to this popular list, because you start with a disadvantage with respect to all the popular web pages starting popular. And of course, since we are talking about active browsing of people, again, the human aspect, all of us know that when we search for something and we get the results from Google, we will go maybe to the half page of the first result. Nobody goes on and on to look at other pages. So this even makes the situation more problematic. Even if you are in the list, but you are on the list down there in the list, nobody will look at you. Okay, and we took these two models. The network model, the web model, and the word of mouth model. And first we tried to see how much time it takes till you can spread some message either as a web page or by using this social network. And what you see on top is that when we talk about the first % of the network, which is a huge number, of course, it is much faster to do it with word of mouth because of this mechanism that I spoke before, because of the PageRank mechanism. It takes much more time to get into the first % of the network, and we use a lot of simulation in order to, when you use a web page mechanism. And not only that it is faster, which is the top view, but it is much more certain because the variance of the worm spreading is much smaller with respect to the variance of the web spreading. So in the web spreading, not only that it takes you more time, but you are not sure how much time it will take you, while the worm is much more faster. And again, the idea why it is easier to spread a new idea or a new malware by a social network, because actually when you get a message from two friends, you don't care if this is something that is actually not so popular in the web outside with respect to all the world, but it's something that is very popular to people that you care, and you tend to accept it. This is the idea. Then if more and more people will accept it, eventually you can reach this 1% in an easier manner. Of course, there is also implication regarding the diversity, and we also checked that. So if you check what is a diversity, and we did experiments with human subject, if you ask them question and you ask people first to use web, or part of the people to use Google to find the answer, and you take the other part of your study, other people, and you ask them to ask their friends, you find that the diversity of ideas is much smaller, of course, in the web page, because again, in the web page you are based on a very popular list of responses. So the conclusion is that word of mouth is much more effective to insert malware or new ideas. And of course, it is very hard to be popular. Even if you look at Facebook and you look at those hubs that are on the top list, you are not there. I mean, it's very hard to be there. And the idea is to create a mechanism that will enable you first to influence people that are around you in a short time, and be enough attractive so it will continue and grow. And I want to show you the idea of this algorithm that we are developing. And then we'll show you some results, and we can end this talk. But let's say that I have a very simple network, like the one to the left, and I have a budget of, I can influence 3 nodes, okay? So I can start by seeding. I just pick, one of these 3, and let's say that I have a threshold, like in a social network, that if 2 of my friends are affected and send me a message, I will adopt it. So you see the third picture there. Since this guy got some message from 2 friends, he will adopt it as well. And when you finish with it, it ends up that you were able to affect, 4 out of these 5 nodes, okay? Because you seeded 3, and then since the threshold is 2, another node was affected. And you cannot do more than that with 3. When you have a budget of 3 nodes, you cannot do more than these 4 out of 5. But let's say now you want to do it in a scheduled way, and you have some visibility how it works. Then you can plug and put those malware or messages in 2 places. Wait that the third one is affected. Then at the same time, or very closely to it, actually affect the 5th node, and then the 4th node will be affected by itself because, again, the threshold is 2. So now with the same budget, you could reach the entire network, okay? And in fact, Alon will show that we can reach even a 25% higher convergence when we use this type of technology, this type of simple mechanism. Of course, it is very hard because you need to know what is the state of the network at each time. You need to have some visibility, and you need to predict something which is very hard to do. But this is what was the aim of the study, and we'll show a few results. And Alon, just come on. Alon is a PhD student that is working on this project.
Hello. So basically, what we're saying here is that we have this is an imaginary story, good for a good script for a movie. Some bad guy wants to infect Obama's computer. So he's trying to infect this computer. Of course, it's the computer of the most protected person in the world. So of course, it cannot penetrate. He's trying his wife. Of course, it's protected. And he's trying his daughters. He's trying each of the daughters also. Of course, it's protected. But then he's find friends of one of his daughter, which likes to download crack movies, and very easily the malware is installed. And now we have just to go 2 hops in order to get to the target that we want to install our malware. So our basic model assumes that there is a cost. There's some cost of making a virus. There's some cost of putting this virus on websites. There's a limited time until the virus is detected, from the time that the virus was first inserted into this website until the time that all the protections are working. There's a time, so the probability of detection decreases. And there's a herd behavior, which means that if one of my friends sends me a link and say, come on, look at this link, it's very cool, maybe I'll be suspicious that it's malware. But if there's like a few friends, especially if they do not know each other, that sends me a link, all of them saying that it's a very cool movie or very cool new stuff, there's the probability of adopting will increase. So the model is very simple. I'll just go briefly on it. We have a graph. We have 3 states. Okay, I'll skip it. I'll just say that you can be infected or already infected, but the search engines and the antivirus know us, so it will not influence. And we have to think also on clusters, but I will not go in because of the time, sorry. So we'll try two of our heuristics. The first heuristic is to insert the virus basically on the biggest hubs, like CNN or really big sites. So insert on the biggest hub, and we're trying to go to see how by those assumptions the virus spread. And we search a certain threshold, a certain number of nodes. If you're trying, on the other hand, to go gradually and to go from the friend of the friend to the friend and gradually infect as we go on, and we see that our virus has captured someone, then see another person, then we can reach a greater percentage of the network. You can see here that the percentage is much higher. So we investigated this algorithm on different networks in different initial conditions. I'll quickly go. We can see that we can improve in different initial conditions. We can improve between 300% to about 15 when we were varying our threshold. In any cases, we have a very nice improvement in the spread, which means that from the perspective of the virus spreader or the malware spreader, he has a potential method to spread his virus in a more efficient way. I won't go into all the details. It's in different graph, in different initial conditions. Conclusions. As much as we can be good in preventing against malware, there's always the human aspect. There's always the person that will click this link and download the malware, which we need to consider. Since we've seen that the word of mouth is a more effective method of spread, for positive or for negative, then we need to consider this method of spread as a spread that would be developed. It's a more customized method of spread. We're going now from generous viruses. We might go to a more precise virus that fits different clusters of people. If you know which viruses live or which malware live in your friend's computer, you might know which viruses live or hack your own computer. While the big hubs were once the thing that we had to protect, now we need to protect smaller hubs because the spread will go into smaller and smaller websites. And the last, I have a very interesting reference about scheduling of information. I have this for 1 minute. It's the King Solomon, the time that he was becoming a king, and there was a rebel. There was a rebel of his brother that wanted to be a king instead of him. So there was it's a biblical story. One of the prophets said to his mother, instead of going yourself and I'm coming with you, you go first, you'll say the message as a rebel, and I'll come just by chance. And said, yeah, that's true, I also have seen this information. And the moment that two information sources come together, the chances of adopting this new information is much greater, and it's exactly the same criterion that our algorithm works on. And that's all. Thank you very much for Professor Ben-Gal, Irad Shmueli, and everyone who helped in this project. Thank you.